All right, we're going to start with Roman numeral 2. Drew has joined us for the class, so it's Drew, Emily, and I, and we'll kind of take things in the same way. With Roman numeral 2, we have a case study here, and this is actually the example from the homework we did last week. Very near and dear to my heart. 3 people with asthma, you designed a program for them to improve their quality of life. You measure the 3 people before and the 3 people after. This type of design is also a repeated measures design. But Emily, do you remember what I called this particular type of repeated measures design? What did I say this was?
You said it was an organized...
Well, that was the other one. This is an intervention. So this is within subject design.
Within subject design.
And we would never counterbalance
without
this.
An intervention.
This one is with an intervention, and so what I wanted to do for both of you is I wanted to actually first show you, so this is within subject as well, but it's an intervention based. I wanted to demonstrate how we would actually use SPSS on this. So what I'm going to ask both of you to do, and the others can do this as well if you're here at the computer, is go and use your mouse, go on to the programs on the bottom, and see if you can go into SPSS. It'll just open up. When it opens up, you can just X off this, Miss Emily. And I want to actually show how we would actually do this. So what I'd actually ask you to do is in the very first column, just put the numbers 1, 4, and 7. And in the second column, put the other numbers, 5, 9, and 13. Just enter, Emily. Now, if you look at this, notice it created variable names. Drew, do you know how to fix this so you actually give it the right thing?
You can get into variable view,
yep,
click on that folder tab, and then you can change the name.
There you go. So click it on variable view, Emily, and just change it to pre and post. And enter. Okay, now go back to data view and notice what it did there in a very simple way. My examples will be simple. Now we said what kind of statistic, Emily? Do you remember what we're going to do on this?
We're going to do within subject.
Yeah, paired t-test. So you go to analyze, and Drew, you probably know this. Analyze, and Drew, do you remember which one we go to on this?
Do not.
Emily, do you remember?
You go to
compare means, because we're comparing the pre to the post, and we do paired sample t-test under compare means, and then you just put the pre. Go ahead, Em. And now click it on the bottom one and post. Have you got that, Drew? Mm-hmm. And then just do OK, and now SPSS goes and does all the work for you. Isn't that fun? So now we have the printout, which is what I did for the homework example there, so we can kind of fill in some stuff once again. This design, once again, is an intervention-based design. Now, notice it's missing the treatment effect. Can you actually look at your screen and see what the treatment effect is, Emily?
The treatment effect is -5.
Yeah, it's a treatment effect, and sign doesn't matter. 5. Where did it come up with that number, Emily? How did it come up with a treatment effect of 5?
From the numbers. And
Drew, could you add to that? How did it come up with a treatment effect of 5?
Subtract the means from each other.
Yeah.
9 minus 4. Does it matter which order you do them in? Or?
Not so much. The sign doesn't matter here. So you get the mean of the pre, it's 4. The mean of the post, it's 9. The treatment effect is 5. That would represent what, the numerator or denominator for the t-test? That's the numerator. We want that number to be large because that would say my program worked. So that's good. The numerator is 5. So the treatment effect is 5. Now, what about the denominator? Remember that miserable formula from last week? Did you ever have to compute that, Drew?
No.
Thank God.
No, okay, thank you. For
Now,
that.
instead of not computing that, what can we just do here, Drew? What is the denominator?
Standard error of the mean.
There you go. The standard error of the mean, and the other one, it's the standard error of the mean difference. That number for the denominator, do we want that, Emily, to be large or small?
Small.
Anything that says error, we want to be small, exactly. So if you put the 5 over the 0.57, what is the result to that? It actually says it on the screen, doesn't it, Emily? If you put the 5 over the 0.57, does the computer tell you what the result is? What's the t obtained score, Emily?
Negative 8.6.
That's right. Negative 8, and you can just make it positive. It's just the pre and the post. So you can just put the 8.660, and so we would do that. Is this result, how often, Drew, how often could you get this result due to chance?
86% of the time?
Not quite. How often does this result occur due to chance?
Oh, 13 or 1.3% of the time.
1.3% of the time. So you could get this result due to chance about 1% of the time. So what would be our decision, Emily, if it was this result could happen due to chance 1% of the time? Would we say that's significant or no?
We would say it's significant.
Exactly. If it's p less than 0.05, you say this is statistically significant. So that is exactly the way here. And you could write this out. And the way we would write this out, and you did this last week, t, and then in parentheses, what would be in the parentheses there, Emily?
2.
2, because we have 3 people, equals, Drew, what would it equal?
Degrees of freedom?
Not quite. Well, 2 in the parentheses, and then equals.
Oh, equals. Sorry, it would be negative or 8.6.
Yeah, you can just make it 8.6. And then, since it's under 0.05, you just write p equals 0.013. That is statistically significant, and would I be happy with my Tausman asthma program?
Yeah.
The program worked, yes. So you would say the program helped people with asthma. Is that good? Okay, let's stop the second one here.